All right. Hi, and welcome to the Supercharged Metal AM webinar. I'm your host, Alex. Here to present today is Kevin, who is an AM engineer with over 7 years of industry experience, ranging from service engineer to customer service leadership. And now his current role as a technical support manager at Farsoon Europe. With his expansive hands-on knowledge, he'll walk us through how innovations like beam shaping and support reduction are enabling faster, scalable metal production. If you have any questions throughout the presentation, please feel free to fill them out at the Q&A session, and we'll cover them at the end of the presentation. Kevin, the floor is yours.
Thank you for the introduction, Alex. Welcome everybody to this webinar where I will showcase the Farsoon 350M and some great serial applications. So first, because you might not know Farsoon, everybody, I will introduce our companies first. So at Farsoon, we have more than 25 years experience in laser powder bed fusion. It fits plastic and metals together. Our founder, Dr. Shu, he created this company because he believed in open system. He had really in mind, like he wanted to create a brand, creating machine like for CNC or injection molding applications. As I said, so we sell LPBF machines all over 30 countries worldwide, and we sold more than 1,200 machines. Here on the bottom, you can see 3 pictures. On the left, it's our headquarters with the Farsoon team in front of the 1.5 meter machine. In the middle, that's the team from America, where Alex is from, which is based in Austin, Texas. And on the bottom right, it's my team, Farsoon Europe. We are based in Germany, in Stuttgart. And this picture was in Formnext last year. We had a really successful booth with 2 industrial machines. We had the 171 machine running with 1 ton titanium powder in a fair. And we also had like a small polymer machine running with PEC material. So in the beginning, I mentioned about open systems. What does it mean exactly? So we see this in 4 pillars. First, it's open system. We really try to listen the maximum to our customers. It means if you're a customer, you have a special needs, you tell me, oh, I want this laser, I want this type of powder loop, I want this different feature, we can make the machine for you. So it's really tailor-made when you need it. But open, when we speak in the AM world, a lot of people are thinking directly about materials. That's also like our philosophy, so open materials. It means, like I said in the beginning, if we take example of CNC machine, injection molding, you take a machine and you put the material you desire in it, what fits the best to your application. But if you want this to be successful, you need open parameters. And for sure, when you get the machine from Farsoon, you have a full list of open parameters. And thanks to this, different layer thickness, different energy, different strategy of scanning, you can really apply the best parameter to your production. And also because we develop our own software, we have an open software philosophy. It means if you want a special add-on, if you want a small change in the software, or if you want a link to a software that you already have in the company, we can make this for you pretty easily because it's our own development. And on the bottom, I wanted to put 2 pictures of some success of the last months. On the bottom left, it's the opening of our new plant in Farsoon, China. As you can see, it's pretty big. It's more than 240,000 square meters. And on the right side here, it's inside of the facility. Here you can see the production line of the 811 machine. And also this was the second news from a few weeks ago. We sold more than 150 machines that can build more than 1 meter metal parts. Really short about polymer, because it's not focused for today, but I still want to talk about it because it's still about 50-50 about the machine sold globally. We have LPBF machine, SLS-based machine with 2 different technology, with CO2 or fiber laser with really high productivity. Machine going from 252, which is more a machine for universities, from R&D, to machine up to 1 meter length. And you have a bit of what you want in the middle, what suits the best to your need. But if you go with the flight 1K machine, you can produce really serial production, and you also have like automatic build job starting. This is really meant for high throughput for serial production. And also I want to mention, we have on the 252P a strong knowledge on high performance, high temperature materials. We are able to process materials like PEC family materials up to 340 degrees Celsius. On the metal side, we also see a pretty big portfolio, going from the smallest machine with one laser, which is 191, is still like about 200 millimeter diameter platform, up to the small monster that we have up 1.5 meter with 32 lasers. We have some bottom feed machine, which are more for R&D purpose. And all the rest is like top feed, because we really target serial production. And for serial production, we consider that you need top feed machine. And you see in highlight here, we have like this 350M machine, which is the topic of today. It's a machine for serial production, but in the middle size range. So first, let me introduce technically a bit about the machine. So this 350M, why it's called 350, because the y-axis of the machine is 358 millimeters. It's a non-square platform, which is in this industry not standard, but it enables you to fit even more parts. So it's 358 by 433 millimeters and a Z height of 400 millimeters. The machine has two optical layouts possible with 4 or 6 lasers. We'll come back to this a bit later. Also, for later points, we have like points like reliability, how we achieve this thanks to a really performant airflow design and permanent filter system. Here we have a point which is ease of use. This machine, the request from our customers was like the smallest footprint as possible. We have customers running more than 40 of this machine in series, and they didn't accept to have like 1 meter more of machine. So it had to be the most compact possible. So if you make a ratio of the build platform size and the 6 square meters, it's pretty impressive. It's one of the most compact machines on the market. And also we mentioned for the powder loop, we have 2 ways, one flexible, pretty manual, and one fully automatic with PHS, with powder handling station. In a third portion, I will speak about the Farsoon innovation that applies to the 350, but also apply to all our models, which a great improvement is beam shaping, support reduction strategy. Going with beam shaping, we have larger layer thickness. And also one point we wanted to mention, we will not highlight it today because it's not the meaning of this webinar, but we can also do fine laser spot with this machine. So you can have this machine to also print copper. This is also possible. Just reach out to us and we can have a special meeting another day. And in a bit more than 2 years now since the machine has been released, we have installed more than 200 of this machine in 15 different industries. So here, welcome in the build chamber, we can say. As I mentioned earlier, and here you can see on the right side, we have like a top feeding system. One reason what makes it really optimized for serial production and really compact. On the bottom left here, you have more the drawing on how the recoating works. So the recoating is in X direction. It's bidirectional, so it's why we have 2 overflow. And the coating time is about 8 seconds, which is pretty fast. And when we have to change the recoater, we assume it's faster than 20 minutes because of the design, and it's pretty efficient. Also, when we have a look inside here of this build chamber, you can see on top, you see here 5 holes. So you have 4 holes because it's 4 laser configuration. So 4 scanners are on top. And in the middle here, you have a process monitoring camera. So with this camera, you can do process monitoring. It means if the camera detects that there is some short feeding, like a lack of powder somewhere, it will automatically relaunch some recoating until the gap is filled. But also if you see some defects, some important warping, it can also stop the build. These are also parameters that you can adjust. You can decide if it has to run through, even if there is warpage, you don't care, or directly for quality purpose, if there is a tiny warpage, you can just stop the printing automatically. And what we also see here in this picture is like the inlets of the multi-layer airflow. That brings us to this page. So all our airflow are now designed thanks to CFD analysis and results. So as you see here on the left, it's multi-layer. So it really ensures reliable part quality across the full build area. We also have some tests we can share to you in private meetings, like with tensile result everywhere on the build platform. It's really consistent, but not only in the build area, but also through the full build height. But if you want this airflow to be efficient and working well, you need a powerful and high quality filtration system. So now at Farsoon, we equip as standard or as on request every machine with permanent filters. We also developed our own permanent filters. And we assume that you can run this permanent filter for more than 3 years with running 24/7. And as you can see on the bottom here, we have a certification. We work together with TÜV Rheinland, and the design has been certified as explosion proof. So one of the topic is how do you work with this machine? Like how is the powder? As I said in the beginning, one of the push of the industry was to have like a really small footprint, something pretty flexible, taking the smallest layout as possible, and cost efficient. So it's how we developed this first way for the powder based on powder tanks. So it means the machine is standalone, and you have overflow. So when the job is finished, you push the powder in the overflow. You take the powder containers, you bring it to the top of the sieve unit. You sieve the powder back in a container, and then you will unload the container in the PCU, it's the powder conveying unit. And this unit will pump the powder to the top of the machine. The machine is also equipped with a 50-liter tank, powder tank. So it means it's autonomous for already a few days. And this PCU can be shared with different machines. So you have different strategies. Some people just leave it on the machine, but you can also use it for 3 or 4 machines. It means you fill this tank up, you go to another machine, you fill it up. This was the idea of this layout with separate standalone sieving, standalone PCU, pretty cost efficient, but requiring a bit more manpower. But I think in this webinar, there are a lot of people from the US and from Europe. We all know what people want. They want fully enclosed, no risk, high standard of safety. And it's why we also developed the PHS, which is a fully closed loop powder solution. It means we will not work with containers anymore. This, you forget about it. It's all connected. The overflow are connected directly to the top of the PHS. So the powder is pumped automatically to the top. It's sieved, going to a tank. And when the machine needs it, it's going to be pumped again on the top. And here on the right, we see an accessory that you can also order with the machine. It's a tube that's in the machine, so you can vacuum the powder through the glove box. And this is fully under inert. So it means like it's a flow of air and inert gas. It's a closed loop. So it means you don't suck. There is never a contact with air. This is also a fully closed loop. Yeah, so that's it about the powder. As I mentioned a few minutes earlier, we have 2 different optic layouts, 4 or 6 laser. With 4 and 6 laser, we have both the option to get with 500 watt configuration, which is you can say like the standard of the industry since years. That enables you to run standard parameters, which are, we can say now, pretty conservative part production. So it means 40, 60, 70, 80 maximum layer thickness. And what we see here, you see when we go from 4 to 6 laser, if we have a really good layout of parts, we can already improve by almost 40% the build time. But the big innovation of this year is beam shaping. That's going to be my next topic. So the 350 is also available with beam shaping with 4 laser configuration with 1 kilowatt. And in this case, using a higher layer thickness, we can almost divide the print time by 3, thanks to higher laser power, beam shaping, and higher layer thickness. Yeah. So that brings me to the Farsoon innovations. The first was really specific 350. Now I want to showcase you the technical features that we have for every machine. So for me and for our R&D team, the big step the last years was really the use of beam shaping. At Farsoon, we use like our own developed beam shaping, so we don't rely on external supplier for lasers or different scanners. And beam shaping, it's not new. It has been used since years in laser applications, like in welding, in laser cutting. It's really well known how it works. So here, nothing new. We just applied the technology to additive manufacturing. So if we compare here on the left, the Gaussian beam, we see like a really high energy in the middle. And that's kind of a limit of this process because we want to have a really thin beam, but then we bring a high stress in this middle of the melt pool. Thanks to shape beam solution, here we have an example of a donut, but other energy distribution forms are possible. We reach way better energy input. So the melt pool is way more stable. Thus enable us to go with wider hatch distance because we can also put more power. And so it's way more efficient. So we see, for example, here, we reach 69% productivity increase with aluminum, keeping the same layer thickness. And also in the future, next slide, we will see we can increase a lot the layer thickness. Here, because it's better to see with your eyes, I will show you a short video. On top, it will be like standard with Gaussian beam, and on bottom with laser beam shaping. Have a look at the speed, the splatters, and the smoke. Yeah, maybe I would just re-put it here. We saw really the melting. I think it's really obvious. I hope the quality comes good across. So I was speaking about productivity increase. As I said, aluminum 69%. We were not even optimistic on this first number because we see in Cornell, copper alloy, we even have higher increase. And since it's written really in small here, but it should be written in big, we speak about the same layer thickness. And here you have some data explaining, for example, with aluminum, 80 micrometer layer thickness, we had almost 50 centimeter cubic an hour per laser with Gaussian beam. And now with shape beam, we are more than 80 square cubic per hour. So you can imagine we still have room with the laser power, and we are just at 80 micrometer layer thickness. So it's just a matter of time. We easily reach more than 100 square cubic per hour. Yeah. And for example, here we see for titanium, we went from 26 with 60 micron layer thickness to almost 90 with 150 micrometer layer thickness. So there is a lot of possibilities. It just needs to fit exactly your needs. So I know the next question because it's always the same. Okay, but is it reliable? Because it's good to produce way faster, but if the part quality is not good, it doesn't bring a lot. So the studies in metallurgic are a bit far away from me, but our experts are really confident to show you this sketch and explain that the grain structure and the size, it's basically the same. There is no really big difference from the metallurgic point of view in the metal, while it's melting with Gaussian or with shape beam. And also the density is kept at pretty high standard. First was really productivity, material properties. What does it bring else? We see, as I said in the beginning, a way better melt pool. So thanks to this melt pool improvement, we also see like the minimum overhang without support can be really decreased. On top here is an example with titanium, and this part is 15 degree overhang. It's With this length, it's almost impossible to print with a standard Gaussian beam. But thanks to the for the shape beam, we see way better behavior for these downskins. So this was the part of the overhang. And so when we do beam shaping, we have to increase a bit the beam. So basically we increase it 2 or 3 times bigger than the Gaussian beam. But it's not because we really increase it that we cannot build thin walls. So here we have 2 applications. One, for example, is with pure copper, and here with titanium. Both have a wall thickness between 150 and 200 microns. So still with beam shaping, we can build like really accurate thin walls. And that's really perfect in like some tooling application, but also like in cooling applications. And one of the innovations that's pretty important is SRS, support reduction system. We all know support in metal printing is a bit annoying for the people who have to rework it. For people who have done it, if you take example of stainless steel, of Inconel, it's a small nightmare. But also sometimes it's impossible to remove the support. If we take this impeller here, it will be closed. It's a cut. You can imagine it's fully closed. It has 25 build angle, downskin overhang. So it means if you build this part traditionally, you would have to put full of support. So it means it's useless in the future because you cannot remove the support. So thanks to like a lot of IT work and like optical calibration, we were able to remove the supports inside at 24 degree, 20 degrees overhang. So this is like theory on the left, that's software, but on the right side you can see the part. And the part was rebuilt this way, we cut it afterwards, and the only support we needed was here on the angles, because this would have been floating otherwise. It's not even hovering, it's in the air. We have parameters for titanium, for nickel base alloy, for aluminum and stainless steel. And we have printed parts that are bigger than 450 millimeters already with this application. So it's not magic, it's not a button you click, there is no support, it works perfectly, but it can really help you in such cases. So I introduced the machine, I introduced our last innovations. And so now I would like to show you what we did in the past with these combinations. So in less than 2 years, let's see the application we worked on. So we have some use cases in aerospace with standard Inconel material, titanium, also pure copper. But the 2 main applications for us with this machine have been 3C application with titanium and aluminum, and footwear for molds with 316 and aluminum, and also like other applications that you can see on the right. So as I said, the 3C application is one of the main users of the 350M machine. The size fits perfectly, the build speed is perfect. We have one of our customers is running more than 40 machines for 3C serial application. So really serial job 24/7. These 2 examples here, it's not marketing, it's really made in 3D printing now. And this customer has been printing millions of parts in titanium. It takes advantage of 3D printing. We have been able to reduce the weight of the part by 20 to 30% compared to traditional manufacturing. We produce way less waste material, but for this market, we had to be really cost efficient. It's consumer goods, so if it's 5 cents too expensive, it doesn't work. So this was really the fight, showing that our machine can do serial production in titanium at pretty low cost. And how we go to this, it's here we take again an example of beam shaping. We started this project with 350M machine with 6 lasers, with a print time of about 300 hours for 4,000 parts. And thanks to beam shaping and higher laser power, we were able to divide this print time by more than 4 times. And then it was cost efficient to work with this technology. Another application that I like a lot because I also bike a lot, it's the use of this 350M with titanium. And it's really ideal for high performance and lightweight parts. In this case, the base plate size is perfect because we can fit 38 parts and the build time is 24 hours. So the cycle time was perfect, the number of parts is great. And according to this user, our customer, it's 60% faster than the traditional casting as they did before. Because you can imagine there are different sizes of bikes, different shapes. So you need to change also the design a lot. But also here in this case, it's also performance gain. The aerodynamic design reduce a lot the wheel turbulence. So it's not just cost effective, it's not just fast, but it also bring things that other technology couldn't bring. And these bikes can be bought in the commerce because all the parts meet the cycling fatigue standard. So it's also reliable, and as it's titanium, it's a bike for life. As I said in the last slide, one of our main applications with the 350M in Asia is the shoe mold industry. A good example is Victory. This company in China, they have more than 40,000 machines running 24/7 mass production. On their side, Victory, they have more than 27 years experience, but just started with AM in 2021. So in 2021 they started, and now they already have more than 40 machines running day and night. And this figure is pretty impressive here. You can see they produce more than 10,000 pairs of mold per year with 3D printing. And thanks to this mold, they were able to manufacture about 300 million pairs of shoe. That's per year. What it brings 3D printing in this case, before that, the mold fabrication was about 8 steps. And now they reduce it to 4 because 3D printing can do almost everything for the manufacturing of the mold. So the mold production is already 200% faster. Another advantage is you need to be a bit familiar with the shoe industry, but there's this popcorn mold. It's a new technology for like running shoes with like this special foam. In traditional molds, you couldn't make more than 5,000 holes in the mold. And now with 3D printing, we reach more than 15,000. So we can have 3 times more holes in the mold. So we also improve the production of the shoe after. It's more efficient and it's better quality. And now I will show you a small video exactly about this topic. So here we are inside a 350M machine. We can see just now the recoating is happening. We can see the 4 laser in actions. And now we increased a bit the print speed. You will see just after how we refill the powder with the PCU. We bring the PCU, we just plug it, and it's gonna pump about 50 liters powder on the top. And here now a nice video of the depowdering. So in Farsoon Europe, we are opening our new innovation center in a few months. Should be targeted in September, October. We will have a 350 there, and you are more than welcome to come see us and see the machine in action. Just drop us a message and we will welcome you at our innovation center. It's in Zellfingen, it's really close to Stuttgart and easy to reach by train or plane. So thank you for attending. I hope I raised your interest.
Thank you so much. Thank you for your time for coming in, and thank you, Kevin, for the awesome presentation. And have a good day, and we'll see you next time.
Thank you.
Bye.